Okay, so now we got a current going around like this. And my question is, what kind of force would be acting on the loop? Well, first, let's look at, we're just going to focus on this part. And there's a reason for that, and I'm going to talk about that in a minute. Let's just look at what the force on that part of the loop would be. First of all, let's figure out the direction. Let's set up our 3 fingers, okay, because anytime you're doing force, you're going to need the 3 fingers. You're going to have your thumb point in the direction of the current, so your thumb should be pointing toward the top of your page. Your pointer finger should be pointing into the page, and that makes your middle finger point to the left. So your force would be this direction. That's the long way to do it. The easy way to do it is say, hey, I am pulling it this way. Nature doesn't like the flux to change, so nature is going to fight that. It's going to pull in the opposite direction. That's the fast and easy, you're on the multiple choice way to do it. Now let's calculate that. Okay, so that's the equation for force is current times magnetic field times the length of the wire times the sine of theta. And the angle between the current this time and the magnetic field is 90 degrees because the current is going up the paper and the magnetic field is going down into the paper, so that's a 90-degree angle. So we could say, okay, F is equal to, our current was 0.9, our magnetic field was 0.3, the length was given to us as 2 meters, and sine of theta, well, sine of 90 is 1, so we don't have to worry about it. So math says 0.54 newtons is going to be fighting this motion. So how much work would it take to pull this thing out? To keep it going at 3 meters per second. Well, let's take that apart. If you remember, work from last year is equal to the force times the distance. We have the force, and did they give us the total length? What did I originally give you? Okay, they didn't give us the total length, so I'm just going to make one up here. Okay, if that was 2, let's say this is 3.5 meters. Okay, so to pull the whole thing out, you would have to move it, you would have to move it 3.5. So that's the distance you would have to pull it. The force that would be fighting you the whole way is that 0.54. So to find the work, it's work is equal to force times distance. So force is 0.54, and your distance would be 3.5 meters. And we get from math 1.89 joules. Okay, you're like, where is that energy going? If I'm fighting and I'm losing 1.89 joules, what is that doing? Well, that's making our little light up. Because none of this is free energy. This all comes down to the conservation of energy. You are doing work, and that work is turning into electricity. You are gaining no energy. In fact, if we're going to be really technical about it, the second law of thermodynamics, some is going to have to be lost as thermal energy. This is a very ideal situation we just did. Please keep in mind that you're not making energy. You're just making electricity. You're giving energy to do that.